And welcome to Otten Math. In this edition of Otten Math, we are going to talk about arcs of a circle. All right, so what is an arc? Well, an arc consists of 2 points on a circle, and all the points in the circle need to connect the points by a single path. So I say this blue line here is going to be our arc. The center of the arc is the center of the circle. So the center of the arc is the center of the circle of which the arc is a part. So the arc is going to, if I just kept on going around and around, I'd form a circle. So the arc is part of a circle, right? And it's all the points in between those 2 points. So not just the 2 points, but all the points, including those 2 points in between the 2 points. The center of the arc is the center of the circle of which the arc is a part. Right, a central angle is an angle whose vertex is at the center of the circle. So a lot of times in math, the definition is in the name. So central angle is an angle whose vertex is at the center of the circle. Now, central angle is going to be less than or equal to 180 degrees. All right, so if I have an arc that's a diameter that corresponds to the diameter, then the central angle is going to be 180 degrees. All right, now what happens, what happens now is if I have a line that runs this way, then I have really 2 potential angles, this one, and then I have this one here. So my central angle in this case is going to be this central angle and not this angle here. Okay, so the central angle is an angle whose vertex is at the center of the circle. A central angle is less than or equal to 180 degrees. Now an angle can be more than 180 degrees, but in this case what we refer to as a central angle needs to be 180 degrees or less. All right, now so let's talk about minor arcs and major arcs. A minor arc is an arc whose points are on or between the sides of a central angle. So the minor arc corresponds to the central angle. So in this case I have my central angle here, and the minor arc is the arc that corresponds to the central angle. The major arc is the arc whose points are on the outside of the central angle. So here's my major arc. Now the confusion comes in defining the letters for major and minor arc. And so what we're going to do is in the case of the major arc, we're going to include at least 3 letters. I have A, D, C. So I know that the arc includes this area that's outside of the central angle. So if I just said AC, right, I wouldn't know if AC was this major arc or if it was the minor arc. So now we're going to say for major arcs we're going to use 3 letters, A, D, and C, or another letter besides the 2 endpoints that correspond to some point on the arc itself. So with a minor arc, typically we'll just use 2 letters. So AC designates our minor arc, ADC represents our major arc. Now I can use more than 2 letters for a minor arc, but we want to just in general use just 2 letters. That should be sufficient to define the minor arc. Okay, so let's talk about arc measures. The minor arc is going to be the measure of the central angle, and the major arc is going to be 360 degrees minus the measure of the minor arc with the same endpoints. So we're going to go back to our original, or our graph that we had before, and we're going to say that this angle measure is going to be about 100 degrees. All right, so the measure of the minor arc is going to be 100 degrees, so it corresponds to the central angle, and the measure of the major arc now is going to be 360 degrees minus 100, or 260 degrees. So the minor arc equals the measure of the central angle, and the major arc equals 360 degrees minus the measure of the minor arc with the same endpoints. All right, so let's talk about arc notation. I think you've figured out that when we talk about arc in shorthand, we're going to write this little umbrella figure that I have in black, plus the corresponding endpoints as the first and last letters. And then if I'm identifying a major arc, I'm going to have at least 1 other letter here in between the 2 endpoints. The endpoints are first and last. Any other points in between the first and last letters, I have this umbrella here, or this hat, as a symbol for an arc. Now I'm going to talk about the measure of an arc. The arc's measure is defined as the degrees, and it corresponds to the measure of the central angle. So that's what we've been talking about so far in this lesson. And I'm going to write shorthand, or lowercase m, and then for measure, and then my arc AB and I'm going to say that arc AB is equal to 60 degrees. So the measure of arc AB is equal to 60 degrees. It corresponds to my central angle. I can also say the measure of arc CD is 60 degrees. Now the length of an arc is something different. The length of the arc corresponds to the number of units in relation to the circumference of the circle. So this should be units. And it corresponds to both the circumference of the circle and the central angle. So I can figure out the length of the arc AB if I know the circumference of the entire circle, and then I multiply the portion of which the central angle comprises of the entire circle. So in this case, I have and I need to find out what the circumference is. I have a radius of 6. My diameter would be 12. The formula for the circumference is pi times diameter. So I know that my circumference is equal to 12 pi. I know that the central angle is 60 degrees, so I know it's 1/6 of the entire measure of all of the angles in a circle. So I know that my arc length correspondingly is going to be 1/6 of the length of the circumference. So 1/6 times 12 gives me 2 pi. All right. So now let's talk about, so length of an arc is the length from A to B, and the measure of an arc measures the relationship in terms of degrees corresponding to the central angle. So actual arcs are congruent to each other. So I have the physical arc, just like we have in triangles. The physical triangle is congruent to each other. So arc AB would be congruent to CD. But when I talk about the measure of an arc, or I talk about the length of an arc, we're talking about a specific number. So I'm going to use the equal sign for that. So when we talk about the physical properties, we talk about congruence. When we talk about the actual measure, we're going to say that they're equal to, because there is the 60 degrees are definite measure. Those values are going to be equal to each other. All right, so actual arcs are congruent or not to each other, and measure of arcs are going to be equal or not to each other. And we write them in this fashion. Okay, so a semicircle is an arc whose endpoints are the endpoints of a diameter. In this case, you're going to want to use 3 letters to define a semicircle, again, because AB could mean this semicircle, ADB, or it could mean ACB. So with a semicircle, just like as in a major arc, and you want to treat it like a major arc, you're going to use the 3 letters with a hat. The first and the last being the endpoints, and then the second to be one of the points on the arc itself. So semicircle is an arc whose endpoints are the endpoints of a diameter. We're going to use 3 letters to define the semicircle. Right, congruent arcs are arcs which have the same measure and are part of the same circle or congruent circles. So in this case, I have the measure of AB plus the measure and the measure of BC, they're both 60 degrees. So again, congruent arcs are arcs which have the same measure and are part of the same circle or congruent circles. And ADB and BDC have the same measure. D is the center of the circle. So I have 2 congruent arcs in AB and BC because their measures are the same and they're part of the same circle or congruent circles. If I take a look at the 2 circles to the right, I have another circle. Let's call this point F, circle F, and circle G. Circle F and circle G are congruent because their radius is 5. I have the same central angle, so G, let's call this, we need to call it something else. So G, we'll call it R, circle R. So GRF angle is 70 degrees, it's a central angle. And also DGC is 70 degrees. So arcs which have the same measure, I have GRF and DGC with 70 degrees, so BC and FG are going to be the same measure, and they're part of congruent circles because the central angle is going to be the same for both with the same radius GD and FR as 5. Right, so this leads us to a bunch of theorems. We have 6 different theorems to go through. Here's the first one. If 2 central angles of a circle, these central angles in red, are congruent, then their intercepted arcs are congruent. So if POQ, angle POQ is congruent to ROS, then arc PQ is going to be congruent to arc RS. So if 2 central angles of a circle or congruent circles are congruent, then their intercepted arcs are congruent. That's one of the 6. Okay. Now, by the same measure in the opposite direction, if two arcs of a circle, so PQ and RS, are congruent, then the corresponding central angles are congruent as well. So two arcs of a circle are congruent, circles are congruent, and the corresponding central angles are congruent. Now, I tell my class that they have to, in some cases, memorize the entire theorem, and in this case, they're going to have to memorize all of these theorems word for word. I don't have a shorthand for these theorems, unfortunately. Okay, so now I have angles to arcs, arcs to angles. Now I have angles to chords and chords to angles. So if two central angles of a circle or of congruent circles are congruent, then the corresponding chords are now congruent. So if POQ is congruent to ROS, then chord PQ is congruent to chord RS. And then the converse of that would be if two chords of a circle are congruent, so PQ is congruent to RS, then the corresponding central angles are congruent. And again, it can be two chords of a circle or congruent circles are congruent, and the corresponding central angles are congruent. So if PQ is congruent to RS, then POQ is congruent to ROS. All right, in the last set, so we had angles to arcs, then we had angles to chords, and now we're going to have arcs to chords. So I have arc PQ is congruent to RS, then I know that chord PQ is congruent to chord RS. So if two arcs of a circle or congruent circles are congruent, then the corresponding chords are congruent. And then again, if the chords are congruent, the corresponding arcs are congruent. So if I have two chords of a circle or of congruent circles that are congruent, then the corresponding arcs are going to be congruent. So PQ is congruent to RS. Okay, so as a problem, I want you to figure this out, and I'll give you the answers in just a second. So I have the diagram as shown. BO is perpendicular to OD. I have A as part of BO. OA is a radius. OB is a radius. BA is 5, and AO is 5. So I want you to figure out what fraction of the small circle is AFC, arc AFC, what fraction of the large circle is arc BJD, which is longer and by how much, AFC or BJD. And we'll make the umbrella here for arc AFC or BJD. Find the lengths of AC and BD. Find the ratio of BD to AC. And then what is the ratio of the measure of arc BJD to the measure of arc AFC? So once you pause for a moment, you can check out the answer, and then you'll be all done. Okay, so the fraction of the smaller circle, AFC, is 1/4 of the smaller circle, because this is 90 degrees. 90 degrees represents 1/4 of the entire circle. Similarly, BJD is 1/4 of the larger circle. We know that BJD is going to be 2 times the length of AC, because the radius is 2 times the length of the AO. So BO is 2 times the length of AO. So correspondingly, the radius of circle O with arc BJD is going to be 2 times the measure of the radius for, 2 times the measure of the arc length for AC. Find the lengths of AC and BD. AC is going to be 5√2, so we just draw this hypotenuse here. I have two 45, 45, 90 triangles, and again BD, two 45, 45, 90 triangles, so I have 5√2 and then 10√2. The ratio of BD to AC is 2 to 1, and then the ratio of the measure of BJD to the measure of AFC is going to be 2 to 1. So the measure of BJD to AFC is going to be 2 to 1. Excuse me, the ratio of the measure of BJD to AFC is going to be 90 degrees for both. So BJD, 90 degrees, and AFC is 90 degrees. So the ratio, the measure of BJD to AFC is going to be 1 to 1. All right, that's it for hot math and arcs and circles. Come and join us for some practice problems in the next edition of Autumn Math.